So welcome everyone to my upgrade presentation. This is a presentation that is based on the last 2 years of work that I've done. I'm very excited to present it all to you today. And as you can see on the slide, the main question guiding my research is how are engineering advice and related modeling insights deployed in energy policy practice? I will get around to how I chose my question and what all this means in a second. But without further ado, I will go through the introduction of my presentation. So in terms of the structure today, I kept it really simple because I only have half an hour. There's a lot more data and a lot more literature that is available, so please do ask after the presentation if you would like a copy of the full report. I'm going to start today's presentation with a bit of background, so the impetus behind my research, how I refined my research topic, and then how I got to my main question and broke it down into sub-research questions. I will then move on to the methods, so that's the sampling strategy, the data collection and analysis, and then the limitations and mitigation techniques that I had in place. After that, I'll go through the results. I've divided that into 3 parts, which match my sub-research question. I will get to that in a minute as well. The first bit will be about what engineering advice means for policy practice. The second is around how engineers and policy analysts interact and the dynamics and the expertise. And then I will end with the importance of models and modeling within all that. The very end of the presentation, instead of a conclusion, I will talk about the next steps for my research and the rest of my PhD, so additional field sites, the reasoning behind that, and how I aim to consolidate my questions and the variables that I picked up on, as well as the additional literature I will draw on. So hopefully all of this makes sense, and I will jump straight into the first part of the presentation. So the background for my research is an article by Adam Cooper, who is my supervisor, who did interviews of 18 policy officials at what was then called DEC, the Department for Energy and Climate Change. The data is from 2012. The article also carries out, on top of original empirical data, literature review of science advice and policy studies, and identifies key articles by most cited debates. It provides an overview of key notions per debate with a focus on the topics covered and the terminology, so to see if engineering advice is mentioned. The authors come to 2 conclusions that are up there on the slides. The first one is that there is a need to consider styles of management, especially for the deployment of engineering expertise within policy. And the second one is that the science advice literature is thought to include engineering advice, but empirical data has shown a discrepancy between engineering advice and science advice literature. Now, what's very important to note here is that the main assumption was that the difference in nature between science and engineering is the main reason for that discrepancy. I think this needs to be nuanced, but we'll come back to that in a little bit. This article, obviously, and those 2 conclusions, I should say, call for more empirical and theoretical evidence. It's just a starting point, and that's how my PhD funding and my PhD research came to be. So the main topic or the main idea behind my PhD is that to fully understand the deployment of engineering advice in policy practice, one needs fresh empirical data, especially with the restructuring of DEC into BEIS, which is the Department for Business, Energy and Industrial Strategy of the UK government. It needs maybe a focus on the engineer's point of view instead of just it being the policy officials. And of course, it needs a more in-depth qualitative literature review of science advice and policy studies that looks beyond just the topics covered, but also the institutional arrangements and policy cultures within that, and not just terminology, but also what the concepts within those debates entail. With all this in mind, I decided to narrow down my topic and focus on energy policy practice. As we know, this policy topic requires engineering advice, so therefore would lend itself well to my project. I was keen to focus on the engineer's working experience, as I said before, and that it also includes the tool that they use, especially models and modeling. So with all this in mind, I came up with my main research question and translated all those insights into the title and question for my project. So that's how are engineering advice and related modeling insights deployed in energy practice? It's a big question with a lot of different clauses. So I broke it down into 3 sub-questions. The first one is, what exactly do we mean by engineering advice for policy? The second one is, why do interactions between engineers and policy analysts happen the way that they do? And the third one is, how do models relate to engineering advice for policy? Now, obviously, I touched on that just prior, but you can see how those 3 sub-questions kind of fit into my topic. I don't have a definite answer today to all of this just yet, but I've started answering in the context of my fieldwork at BEIS and in my literature review, which will be the focus for the rest of the presentation today. So moving on to the methods, I think the first thing to say here is that looking at our main research question, we're investigating how 2 different communities, the engineers and the policymakers, communicate, how they generate knowledge, and how they see themselves. There isn't a framework or a theory for engineering advice out there, so starting with empirical data and then moving on to theory and literature seemed like an appropriate design. So leveraging STEaPP's policy network, I found an engineering advice team working with policy analysts within BEIS, and they work on energy policy question. I reached out to the head of the engineering team to ask about the team structure and the position within BEIS to determine if the team would be a good pilot case study to start answering some of those questions that we just asked. So it became clear that the team and also their sister team, so it's a second engineering team, a second engineering advice team within BEIS, were good samples. Both engineering teams advise policy teams in the directorate on energy policy questions, and both the engineers and their policy counterparts had varying degrees of experience. So given that the teams were valid samples, I asked the head of the team if he could act as my gatekeeper, which they happily agreed to. I reached out to my gatekeeper's team and their sister team after an initial introductory email by my gatekeeper. I interviewed, obviously, my gatekeeper as well as 5 engineers, so that's 6 engineers overall. And then I asked those engineers to put me in touch with the policy counterparts that they work with. So that meant that I got access to policy analysts working on energy questions at BEIS and interviewed 6 of them. Sadly, I didn't have space on the slide to squeeze in more information than that. I think what I should say really quickly is that out of the 6 engineers, half of them had experience working in the private sector, all of them had PhDs. And they had spent more time in their position than their policy counterparts, including 2 of the engineers I interviewed who had spent more than 5 years in their position. The policy analysts, so out of the 6, 2 of them were engineers by training, which is very interesting. And they had a lot less experience in terms of position in their role than the engineers had, with the average being around 1.5 years to 2 years in their position for the policy analysts. So all the interviews I did were between 45 minutes and an hour, did all the transcription myself, checked the transcripts against the recording and added them to NVivo for analysis. I also took notes directly after the interview and during the interview about what I learned from the interviews, my own reactions, the contradictions or overlap between the informant's responses, and comments that would require further investigations. All those notes were consolidated into interview memos and then added to NVivo. In terms of analysis, I followed Charma's grounded theory approach. Happy to answer a question on that. I don't have much time to go into too much detail here, but I started analyzing my interviews as soon as they were transcribed and then started coding them in NVivo in parallel to doing further interviews. So coding here means breaking down interview transcripts into smaller components called codes and labeling those components and then comparing the components between the transcripts. So this is an example of codes that I had across my transcripts. And as the collection continues and the coding continues, you start spotting patterns in your initial codes and you consolidate something called a code book. So after several follow-ups with informants over email to clarify some bits and bobs and some terms that they used, I aggregated my initial codes into focus codes and created the final version of my code book. So focus code encompasses several initial codes like you can see on the diagram here. What you then do is you write memos at each stage of your analysis. So, memos on the focus codes and what they entail and what they mean, and you summarize that, and then you combine your focus codes into theoretical codes or themes, for which you also write a memo so that you really keep track of what everything means and how you got there. I turned the 10 themes that I had, so that those would be the 10 theoretical codes or themes, into search terms for a lit review. So that included policy, so that's institution, governance, governments, evidence, knowledge, expert, advice, engineer, science, model, and then inputting different combinations into Scopus and Web of Science, and then filtering by most cited sources, which return different strands of literature. That would be science advice, engineering and philosophy, models as boundary objects, and expertise in policy. I then carried out a narrative literature review of those fields. Again, happy to talk about that in more detail. Sadly, I have to speed things up a little bit. So in terms of limitations and mitigations, there is a lot to say, and I have limited time. So instead, I will say that ultimately it's impossible to mitigate against all possible biases, whether that's my own as a researcher or my informants. And instead, my focus has been mainly on trying to show that my research is credible and rigorous. That means being transparent about how the research was carried, what steps were taken to make sure that the information is reliable. That means disclosing how the themes, categories, and codes during the analysis were chosen, and also reflecting in the different memos that I mentioned. All of this is available, so if you would like to have a look at all my data, it's been anonymized, and I would be more than happy to provide you with access to either my database or just show you around the database itself. So the final thing to note is that ethnography as a method can only provide a picture of a limited range of reality. And I can't claim that the data that I got is representative of the entire body of British civil servant, let alone other actors, whether it's inside or outside government, who play a part in engineering policy. Now, I hope, however, that this study reveals some of the mechanisms that characterize the engineering advice process for policymaking, and I will build on those for the rest of my PhD, trying to extrapolate across different contexts what that might mean. All right, so that brings us to the results. The first part of the results, as I said, is around the first sub-question that we had. So what do we mean by engineering advice for policy? And I added a little subtitle there, a question of discipline. I'll get around to that in a second. So for now, I can only answer that in the context of what I've studied, but the aim is to understand what engineering advice for policy means more generally by the end of the PhD. With that said, in very practical terms, in the team that I looked at, on a day-to-day basis, policymakers come to engineers with ad hoc email requests and questions on how a specific technology works. Most of the advice consists of explaining a technology in layman's term, or to answer a question by providing summaries, diagram, figures. And sometimes the engineers first need to have a conversation with the policy team to understand what information or advice the policy analysts need. And when a project is outsourced, the engineers also help the policy analysts frame the issue the right way for the consultants and sometimes translate the technical outputs into a specific message for the policy analysts. On a more theoretical level, another big theme that came out of my fieldwork and lit review was that the difference between engineering advice and science advice was very important. Now that relates to the difference between disciplines that I mentioned in the title here. From what I've read and what my informants have told me, there seems to be a difference in topics covered between science and engineering in policy. So it seems to be that policy analysts turn to engineers for advice on technical performance of physical technologies and for evidence on the tools that people use to accomplish things. But that conclusion itself is limited to the data that I have and that Adam Cooper, my supervisor, had in his article. And it's limited to the policy teams at DEC in the case of Adam and in the engineering team I interviewed in my case, which are very similar in terms of setup. I am planning to do more research on this, and I'll explain in more detail what the plan is at the end of this presentation. I think it's too soon to say that there is a difference in topics covered by engineering and science. I am inclined to think that there might be based on what I have seen, but that remains to be validated by further data. A second big thing, and this is really crucial, is that I've noted in my interviews and lit review possible difference in ontology and epistemology between science and engineering. Now, as one of my informants puts it, science is more of a process or a method and is less focused on the outcome. And in science, the answer can be yes or no. Whereas in engineering, engineers have a goal to reach and they're trying to reach it and they want a yes answer. And until they get that yes answer, they'll keep on chiseling. This is a direct quote. This is very representative of how different disciplines might see each other, first of all. And I think what's key to note is that informant actually has an academic background in science, but now works in engineering as an engineer for the government. And this is crucial because I think this distinction between science and engineering holds when we're talking about pure science, so science done in a lab or an academic setting, and engineering, but maybe not so much when we talk about regulatory science, which is science for policy and engineering. So to paraphrase Jasanoff, regulatory science, the purpose of regulatory science is to produce scientific techniques and artifacts that further the task of policy development. Unlike pure science, regulatory science is concerned with practical applications. So by virtue of being more practical and concerned with solving particular problems, regulatory science goals align with those of engineering. In other words, the term regulatory here brings science closer to engineering. Again, I'm planning on doing more research to this, and I'll explain that towards the end of that presentation, but it's very key to understand that right now. Because what this means is that understanding what the difference between engineering and science advice is, if there is a significant one, will determine how I can anchor my own research into science advice literature, but also determine how we can transpose, hopefully, some of the findings of the literature, of the science advice literature, onto engineering advice. The additional data I gather and the literature review I carried out nuances some of the assumptions that my own project rests on, namely that the difference in nature between science and engineering is what's causing that discrepancy between what we've seen at DEC and then BEIS and the science advice literature. Now, I am more inclined to think there are other equally important factors that are responsible for this discrepancy, and I'll come around to that in the next section. So, this brings us to our second sub-question. Why do interactions between engineering experts and other policy officials happen the way that they do? The starting point for this slide, I should say, is a definition of brokerage by Gluckman et al. It's a 2021 paper, so it's a lit review, it just came out. And in there, the authors argue that brokerage starts with the synthesis of evidence provided by the policy stakeholders and end with dissemination of that knowledge on both sides of the science-policy interface. My results clearly show that this definition needs nuancing, and although synthesis and dissemination might be a good way to unpack how engineering advice for policy works, brokerage is a lot more distributed and a lot less linear than this definition makes it out to be. I've got a fancy diagram for this. So what's on this diagram is at the center you have the policy analyst, and around are all the stakeholders that this policy analyst engages. The green ones are the internal stakeholders within the civil service, and the blue one are the external. Note that the engineering team at the very top, you could switch those two. You could switch the bubble that has the policy analyst and switch it for an engineer, because the engineers engage the same stakeholders as the policy analysts do, slightly differently, and I'll come to that in a minute, but it's very important to note. That means that if you look at my informants account, first of all, the dissemination and synthesis happens at the same time. So engineers and policymakers share insights, go back to external stakeholders, gather information, share it, repeat that cycle a few times. It's not step one, step two. The second thing is that everyone in this situation is a broker, right? So the UK government is very horizontal in its approach to policymakers, so it's very consensual, involves a lot of stakeholders. And it follows in those situations that knowledge and evidence don't travel in a linear way. All the actors here exchange information at various points in the policymaking process, which then gets centralized by the policy analyst and the engineering team, but that's only towards the end of the process, which usually lasts for quite a few months. The other very important point is that both the engineering team and the policy analyst balance a lot of stakeholders. And you can see that from the diagram. And that means that brokerage is actually more distributed than science advice. Scholars have previously theorized, instead of having one actor on one end, on one side of the interface, another one on the other, and maybe a broker in between, if any, that's 3 actors. Actually, in this case, the ones that I've spotted, you had 7 or 8 actors already, knowing that some of those actors on those slides are actually like companies or bodies, so they include even more individuals than one. The thing with engineers and policy analysts is that they don't necessarily engage with the same type of evidence, despite engaging with very similar stakeholders. So the engineers will focus on evidence with a heavier technical component, whereas the policy analysts will deal with views that are more sociopolitical in nature. This is a byproduct of operating at an interface, of a socio-technical interface. What's very interesting is that quite often the policy analysts will push back against the engineers, against the technical solution, on the ground that it doesn't fit the cost-benefit approach, especially in the short term, so that it's too costly to consumers or industry in the short term, and therefore they push back against technical evidence from the engineers. This is a very big source of frustration, and I'm going to pick that up in my next steps as well, so important to note this here. The second side of this is that there's the skills and expertise, and some of the dynamics between engineers and policymakers can be explained by a difference in skills and expertise. This, for instance, includes the engineer. So I've summarized this in the engineering skill set and policy analyst skill set. The engineers tend to, or are not, I should say, it's not as easy for them from the start to communicate to different audiences, especially communicate technical knowledge to different audiences and non-experts. Policy analysts are generally better at adapting their message to their audience. With that said, the engineers have a higher technical understanding as opposed to the policy analysts that have a slightly lower technical understanding. Now, both roles require both sets of skills, obviously, because they're both involved in technical policy making, but the balance of those skills shift. And this is what I've tried to capture in that diagram here on the slides. And as a result of this, if you're going to make good technical policy, you need both. You need both analysts and engineers. And by collaborating, they end up speaking the same language to be able to give and receive engineering advice and disseminate knowledge on both sides of the interface. Now, this notion of speaking the same language in the literature is called interactional knowledge. It's a term coined by Collins and Evans, and I will come back to that in a second as well. The other point to note is that both engineers and policymakers have to tell policy stories and create narratives with their data to convince. This is usually how it's done in the civil service, and that means creating one-pagers with a clear narrative and some charts and visuals to convince the minister or the ministerial team that the policy is the way to go. The policy stories is an article written by Stevens in 2011, which is great. I would recommend. I've reused the terminology because it fits with my data. The final thing to note is that engineers feel like they're not doing proper engineering because they're more generalists and they use their own judgment. This is again a byproduct of operating in policy and gaining policy skills. Whereas the policy analysts feel the opposite way, and they feel like, they have good policy skills, but the lack of technical understanding sometimes is a hindrance to their credibility. And again, this is just a manifestation of the interface of operating at the socio-technical interface. The last diagram here I will just quickly go over is just a breakdown of expertise in policy. This is based on the data that I've gathered and then mapped on to different elements that I found in the expertise in policy literature. Page states that there's different types of expertise that are mobilized in policymaking, so technical, process, instrument expertise. If there's any question on that, happy to come back to it. Then the thing is, those different types of expertise are sometimes explicit and sometimes tacit, and they combine explicit and tacit knowledge elements. But as the engineers and the policymakers collaborate, this is what we were saying, there's also an added dimension of interactional knowledge that's creating on top of those two. And even more importantly, expertise is relational. So an expert is actually defined by the others as an expert. So the engineers consider the academics experts sometimes, the policy analysts will consider the engineers the experts, and the ministers will consider the policy analysts the experts. So expertise is in the eye of the beholder in this case. Hopefully this makes sense. Now, back to my point earlier. Some of this is not found in the science advice literature. So some of the results and what I just presented just doesn't exist in the science advice literature. But it's not only because there's a difference in disciplines, but because, first of all, the science advice literature looks at executive agencies like the EPA who exist outside of government, whereas we study advice within a government. So that changes, right? That changes the number of stakeholders, the expertise, all the things that we just mentioned. There's also a cultural element at play where we look at the UK, where the policy is a lot more consensual, a lot less formal than the US, which is a lot more confrontational. And I think that influences a lot the way the policymakers and the engineers interact. There's also a methodological difference, so ethnographic versus document-based approaches. The science advice looks at already made decisions with a limited number of interviews, whereas we look at policy that is in motion through ethnographic methods. Some of those points I picked up do exist in the policy literature, especially the ones relating to expertise, but lack practical data, which is quite convenient for me because I've got the data and it maps on well to the literature, which is the previous diagram I just showed. More to be done in that space as well as I go along with my PhD. So finally, models. So why do models deserve their own slide? Well, so far our discussion is focused on engineering advice, mainly people and skills, but there's also policy objects, right? And the science advice and expertise in policy debate have not traditionally focused on policy objects very much. What's very interesting, especially if you look at models, is that they encapsulate engineering advice and how it works at the engineering policy interface very well. So I've come across a model. They were trying to look at changing a certain threshold for solar farms in the UK without spending too much time on it. it required a collaboration between a policy analyst and an engineer. So initially, the engineer and the policy analyst had a lot of back and forth, and they broke down the main question, and the engineer helped the policy analyst understand the mathematical concepts they might need in the model, so like the impact on load factor, cost of energy, electricity demand data. And the policy analyst was focused on trying to make the policy go through. So pleasing industry, pleasing constituents, lowering the cost of renewable energy, those were the policy views or the policy objectives. And through collaborating, they created a model which encapsulates or creates a forum where the policymakers and the modelers can exchange their views and understanding of a problem. That process encapsulates everything that we've talked about so far. Energy, modeling showed that you needed both the engineering advice and the policy advice. Trust was built over those few weeks. A lot of the exchanges were informal, and at the very end, the policy analyst and the engineer had to create a narrative to sell their model to the minister, despite having a very strong time constraint on the presentation, which made it hard to convey the complexity of the model to the decision maker. With that said, this is a small bespoke model. I've not come across large scale models in my research just yet, but again, come back to that in a second. So to conclude, because I am already slightly over time, I will just go back to my initial question. So how are engineering advice and related modeling insights deployed in energy policy practice? We looked at that with regards to the engineering team. Going forward, what I would like to do is add 2 additional field sites, the climate science team and the operational research team. The climate science team will be really useful because it's going to enable me to look at the difference between engineering and science further. The climate science team sits within the same directorate as the engineering team. It's called SICE, Science and Innovation for Climate and Energy. The science team, because it sits within the same directorate, means it's the same culture, it's the same institutional setup, and I'm going to use the same methods. So I can really isolate the variables to really focus on the difference between science and engineering advice for policy, and therefore see if we can transpose some of the findings from the science advice literature onto engineering advice or not, and understand the role of that difference in nature between the 2 disciplines in terms of advice. The climate science team also collaborates with the engineering team on certain projects and deals with large-scale climate models as well. So it's a great site to study modeling and again how advice and collaboration feeds into that modeling. The second, or I should say the third field site, will be the operational research team at BEIS, which deals with large-scale national energy models and especially pricing and economic concerns within that. Those large-scale models have a big economic component. That will be towards term 3 and possibly the beginning of next academic year. The client science team will be the next team that I will focus on towards the end of this term and next. In terms of data collection and analysis, I'll continue with ethnographic data, interviews, observations, which I couldn't do because of the pandemic. Document analysis for the models will be great. Survey will be very useful to get a sense of how many engineers are there and where they sit within the ministry as well, help with the generalization of some ethnographic findings. And HR data would be useful to understand the impact of to get the profile per discipline or profile per team and maybe anonymized salaries to understand motivation, turnaround, institutional power between the policy analyst and the technical, so the scientist or engineering side. We're looking at getting a freedom of information request with Adam to get that. Literature, I'll expand on what I've done so far and then also probably look into the debates around systems of professions, which is which will be very useful for the data I collect. I have not had time to look at that just yet, but I do know it exists by someone called Abbott, very famous. Finally, the structuring principle. So this draws on everything I talked about in the results, and what I want to look at is engineering versus science, and then larger and smaller models, and high and low expertise. So within those two matrices, understand how the different professions see each other, so that's on the vertical axis, and how that influences advice, how the model size influences advice. Think about the number of stakeholders and points of views, for instance, that we mentioned earlier. How engineering advice changes when the engineer knowledge gets added further up the policy chain or lower down. And of course, then when I say level of expertise, I include skills, power, trust, and experience, and how that influences the advice. So it creates 4 quadrants where we can start seeing how those different variables affect the advice that is given and how it's received. And then I would like to do the same with economics in the second field site. The final thing to note is that obviously all this feeds into each other, so everything will be refined as I go. And with all that data at hand, we can start having an answer to our main question, but also leverage those insights to figure out how you can leverage the experience of the engineering policy interface for a successful or good framing of future engineering policy issues. And with that, let me know if you have any questions, or if you would like a copy of my final report. You can email me or come find me in the office. The final report is absolutely massive. It's about 80 pages or so. Includes the original quotes as well, and a deeper dive into methodology and themes. Thank you very much. Thanks for listening, and hopefully I'll